बराबर। ओके, गुड मॉर्निंग स्टूडेंट। वन में in the electrostat we are going to explain today Gauss law of electrostatic. Take care of Gauss law of electrostatics. What is the statement of the Gauss law? What is the statement of the Gauss law? Before stating, you let us see what is the situation. You just take a point charge here in the free space. Take a point charge in the free space and we will draw a Gaussian surface around the charge. A Gaussian sphere is formed around a given charge. ध्यान से देखना, ये जो डॉटेड लाइन्स यहाँ दिया जा रहा है इसका एक विशेष नाम है। हाँ, इसको हम लोग बोलेंगे गॉसियन सरफेस। क्या बोलेंगे? गॉसियन सरफेस। गॉसियन स्फेरिकल सरफेस। अब क्या होगा? जब आपने चार्ज लिया तो चार्ज के कारण जो सरफेस फॉर्म हुआ उसको हमने गॉसियन सरफेस बोला। इस सरफेस का एरिया को हमने एस बोला टोटल। ठीक है, अब क्या करेंगे? यहाँ सेंटर हमने डिसाइड कर लिया, ओ पॉइंट। और यहाँ से एक रेडियल डिस्टेंस पे एरिया डिसाइड करेंगे। वी जस्ट थिंक ऑफ ए रेडियल डिस्टेंस, यहाँ पर आर वेक्टर्स। ठीक है, जब रेडियल डिस्टेंस यहाँ पर डिसाइड करेंगे तो क्या होगा? अब यहाँ पर क्या करेंगे? रेडियल डिस्टेंस के साथ साथ इसका डायरेक्शन ऑफ फील्ड भी डिसाइड करेंगे। फील्ड को हम रिप्रेजेंट कर देते हैं। हाँ, ध्यान देना, फील्ड को रिप्रेजेंट करेंगे अवे फ्रॉम द चार्ज। फील्ड का डायरेक्शन मैंने ई वेक्टर ले लिया, ठीक है। और एक और हम यहाँ पर कॉनिकल सरफेस बनाएंगे, एक इस साइड में और एक इस साइड में। और यहाँ पर मैं एक कट करूंगा सरफेस। गुड, वेरी नाइस। We have taken here one surface element. We have taken here one surface element. सरफेस एलिमेंट का भी नाम हम लोग रखते हैं। हमने यहाँ पर इसका नाम, ये पूरा जो सैडेड लाइंस है वो एक सरफेस एलिमेंट, इसको हम लोग बोलेंगे सरफेस एलिमेंट। जब सरफेस एलिमेंट बोलेंगे तो हमने एक और भी हम लोगों ने पढ़ा था, सरफेस एरिया। क्या पढ़ा था हम लोगों ने? सरफेस एरिया। सरफेस एरिया के कारण क्या होगा, एक एरिया वेक्टर एक्ट करेगा फील्ड के डायरेक्शन में, एंड वी विल राइट डीएस वेक्टर्स जस्ट परपेंडिकुलर टू द प्लेन ऑफ द सरफेस एलिमेंट। जब यहां पर आ गया, हाँ, जब यहाँ पर डीएस वेक्टर आ गया और इलेक्ट्रिक फील्ड भी आ गया, अब हम लोग क्या सोचेंगे? हम लोगों ने यहाँ पे डिसाइड किया था एक और वेक्टर। हाँ, वो जाएगा किधर? जिस डायरेक्शन में वेक्टर आर जा रहा है उसी डायरेक्शन में आर कैप भी जाएगा, ठीक है, आर कैप भी जाएगा। फिर हम लोगों ने जो एरिया वेक्टर पढ़ा था, वो एरिया वेक्टर के कारण एक और यूनिट वेक्टर एक्ट करेगा, उसका भी आप ध्यान रखें। डायरेक्शन ऑफ द एन कैप, गौर करना, इशारा कंसीडरेशन यहाँ पे। अब यहाँ पर बात आ रहा है कि हाउ टू डिसाइड और स्टेट द गॉस लॉ। फर्स्ट ऑफ ऑल वी विल state the Gauss law. What is the statement? Let us see. The surface integral of the electric field. Surface integral of the electric field. Intensity over any closed hypothetical surface. The surface is called imaginary surface. Imaginary surface called Gaussian surface. Gaussian surface in free space is equal to 1 upon epsilon naught times 1 upon epsilon naught times 1 upon epsilon naught times the total charge, the net charge. Take care of. If you like to say anything, you will write on chat. 1 upon epsilon naught times the net charge net charge net charge enclosed within the surface. Within the surface. Yes. This is the statement of the Gauss law. Let us see and think of what we have written here. The surface integral of the electric field. You have already know the idea of the electric flux. The electric flux, what you know already, total electric flux. Mathematically, we will write here total electric flux, total electric flux passing through the surface passing through the surface, the spherical surface, is given by, we are writing here, given by phi E stand for the electric flux, total lines of force passing. We used to write phi E, which is equal to surface integration of the electric field intensity over the element. This is the meaning of the total flux. And according to Gauss law, we can write 1 upon epsilon naught times the net charge enclosed by the Gaussian surface. We have written only Q, not Q naught. So this very formula is called Gauss law. If you have to state, you have to write the language relating with the formula. Okay. Surface integral of electric field intensity, EDS, is nothing but the total electric field lines crossing the Gaussian surface. We can define also the Gaussian surface as the imaginary spherical surface formed around any given charge at the center of the Gaussian surface. If anywhere the charge is located around that charge, an imaginary hypothetical sphere is formed which surrounds or encloses the charge. This is the meaning of the Gaussian surface. Now let us see how to find this formula and how to prove this formula. So try to write down what we have written here, and then we can explain here the surface element. Now come to the next page. How to prove? Let us see the diagram also. What you have decided there. Q is your charge or point charge at O point. R vector is our radius vectors. Radius vectors. R cap is the unit vectors. Unit vectors along R vectors. A Gaussian surface is formed. A Gaussian spherical surface is formed around the Q. We have also written there in the diagram, S is our surface area of the Gaussian surface. And we know the formula of 4 pi r square. Now let us see how to find the flux. Here, before entering into finding, what you have already seen in the diagram, that ds is the surface element. ds is the surface element. Good. So how to write the surface area vector? Surface area can be written in terms of magnitude of the area element with the n cap along the direction of the area. Here, n cap is the unit vector perpendicular or along the direction of area vectors, ds. All these assumptions have been decided before proving the Gauss law. This is the step to prove. Now, how to write the flux? One thing is more important here also. If we have to calculate the flux, we will write phi E, and total flux we will write here. Total electric flux. This is nothing but the closed interval over the surface interval of the electric field intensity with the area vectors. You put the meaning of the electric field here. How to write the electric field intensity? Electric field intensity is very simple things. There is some step to decide the flux. With the help of the electric field, you can easily find out the flux. So take care of the electric field intensity at any point on the surface, at any point on the surface. This is written as E vectors. If you are writing E vector, you recall that 1 upon 4 pi epsilon naught, the charge located with the r square, with the r cap. This is the formula to write for electric field intensity. So when you are writing this step for electric field intensity, you decide here how to recalculate the flux. Therefore, total electric flux, which is phi E, written in terms of the surface intersection of the electric field intensity with the area. You put the value of the electric field by keeping the surface integration as it is. You write 1 upon 4 pi epsilon naught with the charge r square, r cap, and you also write the value of the ds. What is the value of the ds? ds is mode of the ds with the n cap. So here, by operating to calculate the electric flux, the surface integration is operating over the field and the area. And field has been kept in terms of the charge by the square of the radial distance of the Gaussian sphere. We take all the constant terms outside the surface integration. So your constant term is 1 upon 4 pi epsilon naught. Charge is also not changing. Radius of the Gaussian sphere is not changing. Then the other terms is taken under the integration. The term is ds. And along with that, your meaning of the r cap and the n cap is also there. You know that the dot product of the two unit vectors, mode of the r cap, mode of the n cap, with the angle 0 degree, because both are acting in the same direction. So one is here, and cos 0 degree is 1. So you write here 1. So you can easily remove the terms by keeping the values 1 upon 4 pi epsilon naught charged by r square and integration of surface integration over the ds with the 1. Now you can think of this as equation number 2. And you take equation number 1a for simplicity. Because Gauss law has been taken as one standard formula, equation number 1. And we have written here field for equation 1a. And putting this value into the electrical flux and keeping all the constant outside, we see here we have to find the total surface area of this Gaussian sphere. How to find the surface area of the Gaussian sphere? How to find? What is the formula for the Gaussian sphere? Let us see how to find the Gaussian sphere. Because Gaussian sphere, S is our 4 pi r square, which is the surface area, of the Gaussian sphere. When you are writing this formula for Gaussian sphere and take it as equation 3 and put into, by using the equation 2 and 3, you can easily come to the conclusion that the total electric flux passing through the Gaussian surface, passing through the Gaussian surface is nothing but the phi e, and written in terms of the surface integrals over the electric field over the element. And it is 1 upon 4 pi epsilon naught with the charge by r square multiplied with the surface integrations of the ds, which is what? It is 4 pi r square. Now we see here, we are cancelling the terms. We are cutting all the common terms. And we see here 1 upon epsilon times the charge enclosed. Hence, Gauss law is proved. Hence, Gauss law is proved. This is the step to write. This is the long question. You should keep in mind how to write the different step by considering the Gauss law and how to get the total charge enclosed by the Gaussian surface, how it is related with electric flux, 1 upon epsilon naught times the net charge enclosed by the Gaussian surface. So this very theorem is very much important. You should write over on your class notebooks. If you have any problem in understanding, you can say me. You can write on chat so that I may know whether you are understanding or not. Is it clear to all of you? So how to, yes, let us see once again. You are not seeing anything. You come to the first page and see the diagram to verify your state. अगर कहीं पे चार्ज रखा हुआ है तो उसके चारों तरफ जो डॉटेड लाइंस मैंने शो किया वो एक स्फीयर फॉर्म होगा और उसी स्फीयर के द्वारा चार्ज जो है इनक्लोज हो गया। जब चार्ज इनक्लोज हो गया तब स्फीयर का फॉर्मूला उस पर लागू हो जाएगा और स्टेटमेंट आपको चेंज नहीं करना है। द रूल इज रूल phi A is always written in terms of the surface integration of the electric field intensity. If charge is located at the center, in all possible directions, the electric fields are going away. For simplicity, we have shown here only one electric field intensity going away from the center, and it is away from the surface. Another thing is that if the number of fluxes, number of lines of force passing through the Gaussian surface, that must be one smaller element of the surface is considered. Here is the ds, very small element of the surface, and through which all the field lines are passing. That is why this very small element is considered over the hypothetical surface, imaginary surface. So take care of the statement how it is equal to total flux is equal to 1 upon epsilon naught times the charge. ये बात का ध्यान रखना होगा। जहां तक सवाल है इस फार्मूला को लाने का, तो वो फार्मूला का जो स्टेप है आपके पास वो है यहाँ पे, ध्यान देना। मैंने सेकंड स्टेप लिया, ऑल थिंग्स रिटन हियर, Q is the point charge, R is the radius vectors, R cap is the unit vectors acting along R. The Gaussian hypothetical surface is formed around the charge, which encloses the charge. If whole Gaussian surface has surface area, it is equal to 4 pi R square. How to decide the ds? ds is supposed to be the surface element, which is a very, very small part of the total Gaussian surface. If you are writing the area vector, you must take care of how to write the vectors. Vector is equal to the magnitude of the same vector, but attached with the unit vectors acting along the direction of the area vector. तो यहाँ पर जो मैंने किया n cap, ये आपको डिसाइड करना है। n cap का नाम आप बता दो, it is the unit vectors acting along the area vectors. अगर आपने इतना जान गए तो EDS over the surface integration over the EDS will give us द इलेक्ट्रिक फ्लक्स। इसकी बात का स्टेप में जब आप जाते हो तो you come to the point where is the direction of the electric field. If electric field is going out, we can write 1 upon 4 pi epsilon naught charge by r square with the r cap. It is written in the vector form. And we have supposed here this is any equation A, 1A. And coming back to calculate the electric flux with the help of the surface integrations of the electric field over the ds element. And putting the value of the electric field by 1 upon 4 pi epsilon naught q by r square with the r cap. And also putting the formula for the area vector, magnitude of the ds vectors with the n cap, and writing for the dot product of the two unit vectors, which is equal to the 1. If you are putting 1, you vanishing all the unit vectors terms and keeping only the surface integration over the Gaussian element. And ds has sense of very, very small part. ds, yes, ds, integration of the ds, you can write here, integration, closed integration of the ds gives the total surface area of the Gaussian surface. And it comes out to be 4 pi r square. And by using these two equations 2 and 3, you can cut all the values and get 1 upon 4 pi epsilon naught into q. And we get the value of the Gauss theorem. So this is the way to write and this is the way to revise. Okay. So take care of and you will revise this. Any problem? Any of you, if you like to say? Bolo? Any of you? Bolo? Okay, I'm concluding these lectures today and you will once again appear in the next session class.